Today we are going to prove that the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180 degrees. First, let's look at what are the facts. What are interior angles? Interior angles are the angles created inside a shape. Notice that this triangle has 3 interior angles. Now let's define convex, specifically regarding polygons. A polygon is convex if, for any 2 points, P and Q, in the interior of a polygon, the segment PQ lies completely in the interior of the polygon, seen in the example on the left. Segment PQ is completely inside the polygon, while in the non-example on the right, PQ, the segment PQ, kind of exits the polygon and returns back into the polygon. That's not allowed. And note that any polygon with an interior angle greater than 180 is not convex. Now we can ask ourselves, what is an n-gon? An n-gon is a polygon with an n number of sides, ending n being a variable that represents a number. So it can have 5 sides, it can have 6 sides, it can have any number of sides. So now I can ask, what do we already know? Just from basic facts that we've already discovered within our last couple videos, we know that the sum of the interior angles of a triangle is 180 degrees. Additionally, any quadrilateral, which is a shape that has 4 sides, has a diagonal that splits its interior into 2 separate triangles, seen in this image here. So the quadrilateral is split in half into 2 triangles by a diagonal. So now let's get to the proof. There are a couple methods to prove that the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180. And the first proof we're going to look at is the vertex method. So you see we have an n-gon here that actually has 1, 2, 3, 4, 5, 6 sides. So that would be a hexagon. And the first thing we're going to do is choose one vertex. I chose the one at the bottom left and right where it says not dark. And then we're going to draw lines from that vertex to each of the other vertices, which is where the sides connect. And then I darken the opposite sides with respect to the vertex of each triangle. So as you can see, I colored in black the opposite sides of each triangle with respect to that vertex. So as we notice in step 4, this n-gon has n minus 2 dark sides. So we have a certain amount of sides in total minus the 2 not dark sides. And each triangle has 1 dark side, as you notice. And so therefore, there are n minus 2 triangles. So the sum of the interior angles of this n-gon is 180 degrees times n minus 2. Because we know that there are n minus 2 number of triangles which make up the n-gon. So then we know that 180 degrees, which is the total amount of degrees in each triangle, times the number of triangles. So then we get that our n-gon is 180 degrees times the number of triangles, which is n minus 2. Our second and final way to prove that the sum of the measures of the interior angles of a convex n-gon is n minus 2 times 180 is the interior point method. I drew another polygon here in this image, and I chose the point in the interior. Then I drew lines from that interior point that I drew to every vertex, which we established is the connection of all the sides, thereby composing the n-gon into an n number of triangles, in this case 6 triangles. Therefore we notice that there are 180 degrees in each triangle, and the center angles of this polygon and all the triangles that compose it equal 360 degrees. Then the remaining angles, which are on the outsides, form the interior angles of the entire polygon. So therefore the sum of the interior angles is 180 degrees, which is the amount of degrees in each triangle, times n minus the 360 degrees created in the middle. Therefore 180 times n minus 2 is our conclusion. Thanks for watching.